Thanks, everybody. Quick poll. How many people today are doing live streaming? Awesome. Anybody have issues with latency? Would love to see it lower. Excellent. Okay, so we're going to talk about basically 3 ways you can do that already. So just following up from the last session, just a shameless plug for Limelight, since you were talking about 4K and CDNs and so forth, that we do that. So kind of everything he said. So good to know. We're not the only ones, but just throw that out. So what we're going to do on the agenda here is talk about just adoption, just live streaming in general. We do a poll of customers and users around the world every year, like 10 countries, about their online video habits, which is available on our website. I just pulled a few key statistics out that are interesting to this audience. We'll talk about some of the use cases driving low latency, to as low as possible. And it's sort of life beyond flash. Everybody knows it's going away, it's over, and sort of now what? And we'll talk about some transition strategies, because nothing happens overnight. You don't just have a cutover. Flash, everybody asks me, how long is Flash going to be around? God, I think for years, even after 2020, when Adobe's given up, there'll still be Flash out there. And so we'll talk about how you deal with this in transition. So the first part of the data we ask is, how much online video do you watch weekly? And since we do this every year, we can compare. This is the 2017. All these graphs have been sort of creeping to the right. In other words, they're viewing more hours more and more. So the people that only watch an hour or two, that's going down. And the people that watch a lot more hours is going up. And if I compare these over the last several years, it's just walking its way to the right. And we expect that to continue. On devices, so you got to support a lot of devices, because as you can see, they watch it on everything. So the streaming devices, Xboxes, and so, oh, somebody told me today Xbox does not support 4K. Even though they'll display it, they won't ingest it. So I didn't know that. So you have to support a lot of devices. And the other thing that's coming up is a lot more live. So early days of streaming was a lot more video on demand. We're definitely seeing quite a bump in live right now. So it's news, definitely sports. Sports always is one of the things that they jump into things early. And then online video gaming and gambling. Gambling, I sort of as subtext, because if I was talking in APAC or EMEA, I'd spend more time on gambling, because we don't really have that so much in North America. But it's a money use case for low latency streaming. So for live sports, the way it manifests, everybody's seen this. If for some reason you can't get at a broadcast television or a sports bar and you're watching a sporting event, you might get a tweet about, wow, what an awesome goal, or wow, how did he make that catch? And you're like, what catch? And then 30 seconds or a minute later, you see it. Or you're having a party and you have like sort of multiple TVs and you notice that there's this latency there. And so the reason that happens is, one is you put a lot of buffering in, because you never want to rebuffer on a live stream, bad. So typically when you're streaming HLS or dash out, the standard has been like 10-second chunks, and you build 3 of them before you start sending. So right off the bat, even without anything else, there's about 30 seconds of latency. So that's a problem. Online gambling, if you're not outside of North America, this is a money thing, because when you're playing anything online, you can't deal the next card until you've seen the previous card, right? And so if there's a minute or a minute and a half latency between, that slows down the rounds of play. If you're slowing down the rounds of play, that means per hour there's fewer hands dealt. And if you're a casino, fewer hands dealt per hour means your revenue's cut. So if you can get the latencies down, you can play more rounds per hour and there's more revenue. So there's nothing like a lot of money involved in things to spur innovation. So that's a key thing out of, and because of Flash going away, they used to do this with Flash. This has been a huge problem where a lot of CDNs and a lot of browsers are all no more Flash. So the gambling houses are like, what are we going to do? And then video games. You're playing live games and you're trying to shoot at something. If you have 30 seconds of latency, the thing you're trying to shoot at isn't even there anymore when you pull the trigger. So there's a problem as well. So sort of why is it going away? Well, one is HTML. There's always been a lot of security risks, especially with DRM, and it's a pain. People are sick of the constant updates they had to do. Apple didn't support it. I've even found there's an Occupy Flash movement when I was doing some research on it, and they're fighting every day to get rid of this. And then finally, Adobe is they're taking the punch bowl and going home, and it's over. So, what's the solution? Low latency live streaming, and we're going to talk about multiple ways of doing this. I want to put up a workflow first, simplified, because when you talk about latency, you always have to set latency from where to where. And complicating this is some I wouldn't say deliberately confusing, but some confusing things I've heard. Like one CDN vendor said, you know, we do low latency streaming. We could even beat the broadcast. And when I sort of listened carefully about what they talked about, they were talking about ingesting into the CDN right out of the video truck, getting it there, and versus the broadcast. But the funny thing is, you have to do closed captioning. So the broadcast signal is going through the usual closed captioning, which often involves sending the video over maybe to India, where somebody's listening and typing it in and sending it back. And you say, well, you know, if you skip all that overhead stuff and you just stream it right into the CDN, you can get it there faster than the broadcast. But, you know, what good is that? Because that's not reality. So when I'm talking about latency, I'm talking about sort of apples to apples. At the same time, the broadcast sort of operations center getting it, you're injecting it in the CDN. So you're comparing the same thing. So it's when we get it in. The other interesting thing about doing this live streaming, of course, is lots of devices. So I just really quickly put a few of them that I can think of. So between social media, different devices, TV, smart devices, you have a lot of different devices and things you have to support streams on. So it's not quite like broadcast. So when you're shopping for CDNs, you want to make sure that you can deliver to all these devices and this is not even talking about all the different formats and screen sizes. So there's a lot of complication there to add to your shopping list. So, got to replace flash. So here is 3 ways to do it. 2 of these actually are in production today. People are actually doing this stuff today live. So one is just live streaming small chunk size. So one clear way to get it down, instead of 10-second chunks, why don't you reduce it to 1-second chunks? And if you do that, you're down to about 3 seconds before you send it out. Then you have a little bit of time to ingest it, encode it, et cetera. So in production, we're seeing something like 5 to 6 actual real latencies out there, and there's people that's pretty good compared to 30 or a minute and a half. They think, you know, 5, 6 seconds is pretty good. And in this way, we're doing the transcoding in the CDN. So it's just coming in RTMP and we transcode. Now, a lot of people like to do their own transcoding, and they're good at it. They like to do it. They like to have that control, and all they want to do is use the CDN for distribution. And you can do that too. And if you do that, when we get in, so when you transcode it and send it to us, you do the chunking down to 1 second. And you send it to us and we just zip it across the CDN real quick. And they just want to take advantage of these, you know, the points of presence CDNs have globally for distribution. And then you're gonna see about 3 seconds. But ultimately, we'd like to get it down to 1 second like flash, and WebRTC will do that. So one caveat on the small chunk size, that sort of depends on how good and clean your networks are, per the previous discussion. There are parts of the world where that ain't gonna work. So you can start at 1 second and see how it goes. The customers that are doing this have tried that first. If 1 second doesn't work, try 2, you know, and they try to find where the sort of the sweet spot is. In markets that have really good internet connectivity, like parts of APAC, most of North America, you know, Central Europe, it's working really well. I can tell you in India, you know, you're going to be making that chunk size pretty big. So we'll look at each one of these sort of in turn. So the live encoding, so everything just gets reduced by an order of magnitude. So chunk size goes down, so the start time is really quick. Now it's 1 second to go out, and then you have a little bit after that. And in production, as I mentioned, we're seeing about 5 or 6 seconds. So here, RTMP comes in, and HLS or dash goes out, and that's built into the CDN. Or you can do this. You can do your own encoding, set that size, deliver the already encoded dash chunks to us, and we'll just zip it right through and accelerate it and get it out. And this is also in production, and we're seeing realistically about 3 seconds latency. So at the moment, that's pretty good until we get to the real thing. Now, is WebRTC going to be the thing? You know, the jury's out. We're sort of jumping ahead. We're sort of trying to get ahead of the game and figuring the earlier you jump in and play around with stuff, the more you learn before everybody else gets in it. So what we like about this is almost all browsers support it. The only laggard is Windows, but that will happen in 2019. But all the other browsers support it already today, so that's kind of nice. WebRTC has been actually around a while. This is a Google creation, and it was originally designed for peer-to-peer browser communications. So what's being used here is only a subset of its capabilities. So we're not doing peer-to-peer, we're just doing one-to-many. So we're just doing unidirectional streaming. But there's some capability in there to do peer-to-peer in the standard, and there's also a built-in data channel, so you could do some out-of-band communications. And this has a lot of play more in the gambling industry, but there's some capability there. We're not trying to take advantage of these other two things yet, but keep it in mind for the future. What's different about it, it's not TCP. This is UDP, so you're hopping on. These are persistent setup connections, and the way you deal with network problems is you just jump to a lower bit rate connection that's already been set up. So instead of having to retransmit and so forth, it just jumps connections. So UDP is the only way this would work. This is not chunk streaming. You're going to see this in production in 2018. I don't want to pick a quarter. I think we'd like to do it by mid-year, something like that. We have POCs actually live. We're doing one in EMEA, one in North America, one in Asia. We're looking for more. And we're happy so far with, latency's looking really good. So how do you do the transition? So many CDNs have stopped supporting it. Some have not. There's several that have not. We have not. We continue to support it. We have customers that continue to deliver, especially in parts of EMEA with gambling, and they're still using Flash. The customers are using plugins in their browsers to be able to do that. So that's how they're supporting it. Now, all these browsers that support WebRTC, most of them will let you, if Flash comes in, you have to explicitly okay it. So it says, is it okay to put the plug in? You click and then go. And you have to explicitly sort of opt in to do that. So in this transition, we'll output both Flash, RTMP, and HLS and Dash. And then when 2018 comes and we're ready, then another output will just become WebRTC. So in the transition, you have the option of doing all these formats. And as your users and adoption comes, you can do that without changing your workflows. It's just all there very flexibly. So for live, each stream can be RTMP or HLS or Dash, and then the RTM, and then just again add WebRTC to that. Just another output. Video on demand. WebRTC doesn't really mean anything there. So the CDN encodes both into Flash today and HLS and Dash, and you just use MP4 on the fly. So when we store video files in the CDN, we always use MP4 format. It's a good way to export it and use it in other things. And then you can quickly pick it out directly, or we'll encode on the fly and send out HLS or Dash as we go. So short and sweet, that's the story. Questions? I think we have a couple of minutes, maybe. Oh.
Hey, time for questions.
I usually go overtime.
Well, you were quick today. All right, I see a question over here. Somebody?
No, the one up here.
All right, do we have some questions for him?
There's one up here.
One up here. All right, very good. Let's hear it.
What kind of codecs are supported with your WebRTC setup that you guys are working on?
I don't know. This is where I'm going to fall back on. I'm in marketing. Actually, if you give me your card, somebody from our video group is coming in today. He won't be here till this evening, but he will know that because he's managing those trials. I've been told that I just don't have the name off my.
Good job, you stumped him.
You did, stump the speaker.
That's always our goal. Okay, we have one more.
Unless one of the other Limelighters happens to know that I see sitting back there. They're shaking their heads. No help, huh?
They're not volunteering,
okay.
huh? Okay, one here. Oh, good. All right, let him have it.
Hi, I'm Neil. You mentioned how there's different latency across geographies around the world.
Yes.
So do you offer any tools to monitor that, or how would we maintain?
Sure.
So we can set the right chunk size and stuff.
Right. So let me give you so the question is about latencies around the world. So let me tell you a little bit why this will get deployed. So one of the things CDNs do because we have to distribute everywhere in the world, we don't try to do that from one spot. So if you look at any CDN global map, if they're a global CDN, you'll see pops in all the places you'd expect, all up and down APAC, Korea, India, all around the world, North America. You're everywhere in the world you'd expect to see network pops. Pretty much all the CDNs have those. We're all using, we use all private fiber links. So we don't use the internet, but we use all fiber links. So when we deploy WebRTC, what has to happen is the special software that you use to do this has to exist in the POPs, because you always want to deliver as close to the user as you can. So one of the things we're trying to understand as part of the POCs is not only what is the latency, but scalability. So if we take a vendor's WebRTC software and we put an instance of that in the software in our POP, we want to understand how many streams at what bit rate can that one piece of software go out. Like they're usually virtual machines. And then that tells us, well, then how many virtual machines are we going to need to run? So the way deployment will happen is as customers want to use this and they understand, is that my 2-minute warning?
No, who's on our audio?
And as we understand sort of how many users they have in the area, then that tells us how many virtual machines to deploy to do that. So we're going to kind of roll it out where the user demand is. Like all CDNs, you tend not to build out things until people want to use them, not build it and hope they come. So we're going to try to control latency also by just having the density of POPs where you can pull this from around the world. But just generally in the CDNs, we have monitoring points throughout our network, and a lot of our customers allow us to get the beaconing data from their players. So when we do a live event, there's always people in the NOC that are sort of babysitting the live event, and they're getting the data from the CDN, they're getting beaconing data from the players themselves. So we know what the quality is and what the latencies are and so forth. So if there's a latency issue, you can do some tuning on the fly. And so I watched, remember the first, last year, the first Twitter Thursday night football game. I was curious on just how that was going to look. So I had my big TV on and I had my laptop on. And when it started off, pre-roll commercials, there was about a 30-second latency. And I noticed a few rebuffer spins. I said, ooh, that's not going to be good during the game. But when the game started, the latency went up to a minute. And then during the whole game, it eventually went to a minute and a half. But during the whole game, I never saw a rebuffer. So that means that in the NOC, we were watching and just, ahead of when it might have happened, they just, tweaked a little more buffering just to make sure it didn't. So I expect one thing WebRTC should do is it'll help that situation so you don't have to, play so many games at this. But we're encouraged so far. Again, it's early trials. I wouldn't call it a beta. It's a POC. Anything else?